Hello everyone. Today we're going to be talking about Python tuples, also called tuples, so that's up to you, tuple or tuple. So a Python tuple is a specific structure in Python, and it's very similar to a list, except that a list you can change the elements, but a tuple is immutable like a string, so you cannot change the elements of a tuple. Let's see how you create a tuple. So there are the number of ways in which a tuple can be created. A tuple is marked by parentheses, so you can create an empty tuple by just passing the parentheses. So my tuple is equal to an empty tuple here. Now it's not going to be much use creating an empty tuple, because remember, you can't change anything. So if you create an empty tuple, you are stuck with an empty tuple. So better to put something in it, and you can put anything in it, just like a list. So here we are putting in integers. My tuple will be 1, 2 and 3. These are the 3 integers within that tuple. You can print it in C. You can also have mixed data types. So you can have an integer, a string, a float, or anything. Absolutely anything can go inside a tuple. You can also have nested tuples, so which basically means a list or another tuple also can go within a tuple. So this here is a nested tuple. It's got a string, a list, and one more tuple inside it. But as I've said before, all of these elements, once you put them inside a tuple, you can neither add nor delete nor change any of them. Let's see how the output looks like once we run the cell. So you're printing my tuple. For the first one, it's an empty one, and the other 3 have got something within them. And every time you see the parentheses outside, so these parentheses indicate to you the nature of this object, and that's a tuple. Now you don't have to use a pair of parentheses to actually create a tuple. You can use something called tuple packing to create a tuple without the use of parentheses. So in Python, you can assign multiple variables on a line, you know that. But if you're assigning a single variable different values, so you've only defined one variable here, but you've given it 3 different values, then these are going to be packed inside a tuple. This is called packing. Once you've done the packing, it's also possible to unpack it. These 3 elements are going to exist within the tuple, so you can refer to them like this, in this way. Now you can say ABC is equal to my tuple. So these are 3 variables which have been given my tuple. So in this case, my tuple is going to be unpacked into A, B and C. So you can print them out like this. Let's run this and see. So this is about packing and unpacking of a tuple. Now there's one special situation here, that if you want to create a tuple with a single element, then you cannot have a single element within the parentheses by itself. You will need to specify that it's a single element tuple by having a trailing comma behind it. So if I try to say my tuple is equal to hello, one single string, even though I have put the parentheses, Python is going to read it as a string variable. Let's run this and see how it works. So I'm trying to print the type of my variable here, my tuple, but it is actually a string variable because we did not put a trailing comma here. Once you put a trailing comma, it is identified to Python in the form of a tuple. You can also do it this way because the parentheses are optional. Remember, for a single element tuple, parentheses are not necessary, but a comma is. So this is how this works. Now once you have created your tuple, you would like to access the elements that are there in the tuple, and that can be done in the standard way using indexing, because like a list, a tuple is also an indexed and an ordered structure, and the same rules apply as they apply to lists. We can use the index operator to access single elements or a range of elements, which is called a slice. So let's see how these things work. My tuple is a set of individual characters, PERMIT. So there are 6 of these here. Index positions would start at 0 and go to 0, 1, 2, all the way up to 5 at the end of it. So if we print my tuple and use index position 0, we're going to get the very first element here, which is P, which occupies index position 0. My tuple 5 would similarly end up giving us the element which is existing at position 5. If you give a value to this index operator which is out of the range of this tuple, so if you put something more than 5, it's going to return an error to you. So my tuple 6 is not going to work for this particular tuple. Also, just as in lists, indexes must be integers, So you cannot try and pass 2.0 because that would not work. This can be important if you are trying to pass a value which you have retrieved from a different function. So if you are doing that, remember to convert it to int before you pass it. Now for a nested tuple, the indexing works just like it would work for a list. So here is a nested tuple. It's got the first one is a string, the second is a list, and the third element is a tuple. So now we are referring to the 0th index position, which is mouse. Remember that a whole string is itself a structured element and it's got index positions within it. So m would be index position 0 within the string. When we say print tuple 0 and 3, so position 0 refers to mouse, and then we are further specifying the third element of mouse. So that's going to be index position 3, which is S. So we're going to get S out of it. Let's run the cell. So this is the S that we are talking about. These P and T are outcomes from up here. If we are printing n tuple index position 1, element position 1 within that index position 1, so this is what we're going to generate. So this is exactly the way lists also work. And for the same reason, you can also use negative indexing. So just to take a look at it, my tuple is PERMIT, these letters there, and if I say -1, we start counting at the other end. So -1 is going to return T, -6 is going to return, from counting from here, -1, -2, -3, -4, -5 and -6. So these are the outcomes that we get using negative indexing. Now these were all referring to single elements, but we can also pick out a certain selection of elements using the slicing function. So we need the colon here in order to get a slice. A colon defines a gap between the start and stop positions. So if my tuple is PROGRAMIZ, and these are the index positions which I have marked out in the comment just below it, so it's a better fit for you. You can have a better idea of what's going on here. If I am trying to print my tuple and using a slice operator, I want positions 1 till 4. So 1 will be included, 4 will not be included as is standard in Python, which means I'll get positions 1, 2 and 3 only. So ROG, this is going to be our outcome. I'll run the cell. So you see ROG up here. Now if we want elements beginning from the beginning and going all the way up to the third last element, so I want from all the way from here till M, I don't want to include these two. So I can tell Python, do not include -1 and -2. So if I don't want to include -2, I can just say don't include -2, because the stub terminal will not include the element I've passed here. The slice operator tells Python that yeah, go ahead and take all the others except all the way up to -2. So we get PROGRAM and we skip out on the last two ones. Now here we are trying to say, Python, I want element 7 and everything that comes after element 7. So element 7 is I, it will be included. So I and Z are what we're going to get out of this. This is the output of the code. And you will be given these notebooks, so you can try and running them yourself and you can change the values and see what happens. If you put a value which is not within this particular tuple's range, you will get an out of range index error as well. And if you do not give any arguments, just the slice operator, the colon, then you get everything that is contained within the tuple. So the whole thing is printed out for you. So this is how slicing operates. Now I told you tuples are immutable, but what if you really want to change a tuple? You made a mistake, you want to change the tuple. What happens? Well, you could have a tuple like this, and if you try to change it, then you're going to get an error. However, what you can do is, take a look here. This tuple contained a list, and a list is a mutable element. So Python is not going to look what's happening inside the list. All it cares about is that there's a list here, and I'm not going to change the fact that there's a list here, but within the list I can change things. So now I can access my tuple 30, which is going to refer to the third element, this one, the list, and the 0th position 6. Now I am reassigning this 0th position to 9. I can do that because the list itself is a mutable structure, and this will not return an error. So this is one way to go about, and running the cell shows you that it has changed. And the other way is, obviously, you can always reassign your tuple. So you don't want all these values, you don't want any of these, you just want to have these letters in there. So you can just say my tuple is no longer this, I am reassigning it and I am giving it a new structure, and that works. It works for everything in Python. It also works for tuples. In this case, obviously you would be losing all the data that you earlier had in the tuple. Finally, we come to how one can delete a tuple. So use the del word, and in Python the del word works for deleting everything. In a tuple you can't use clear or remove or pop, because the tuple as a whole is immutable. So those things are not going to work, but del works. So you say del and you pass the variable name. In this case the variable name is my tuple, and once you have run the del command on it, if you then try to print my tuple, Python will not find a reference to it and will return an error to you. So this is how this thing works. So that's all about tuples. I hope you enjoyed the session. Good luck, and I'll see you in the next one. Take care.